Okay, welcome, welcome. Thanks for coming. And this is the week 2 webinar. It's our second webinar. And let me tell you the plan of today. We'll start out with any questions you might have. I'm always happy to answer questions. So Q&A time. And then after that, we're going to get into probability. So probability, this is chapter 3, by the way. Probability is very important. And I will let you know that a lot of people have difficulty with it. I'm here to help. The tutors are around to help. We can definitely help you out with this stuff. And I'm going to go through a lot of the different things in probability today. We only have one chapter to do this week. And part of that is because it's one of the more difficult chapters that people struggle with. So cut up to one chapter. So, so then I'll do some examples. So for example, how likely can I win the lottery? Okay, will I win the lottery? Who knows? We'll see. Okay. And we'll talk about what is the probability of winning. Okay. Then we'll get into, I know this looks really easy, and. So when you see the word and or something that kind of corresponds to the word and you want to compute the probability of something and something, how do we do that? Then we'll get into or. So find out the probability of something or something else happening. And that'll be different than the and. And then we'll get into given. So what is the probability of this thing happening given that you know this other thing happened? Then we'll get in what it means to be mutually exclusive. Okay, so a little bit of language here. And then finally, we'll get into what are independent events. So what does it mean for events to be independent or in particular dependent also? So that is the plan today is we'll get into probability. And then after going through chapter 3, I want to talk about project 1 because hopefully at this point you have partners because again, you've had a whole week now to find partners and all you have to do is post on the project 1 discussion board and say I need a partner and then someone will answer and then it'll happen. So if you haven't even looked at that board, then you need to get there because you want a partner now. That's important. So we'll talk about the project, the details of the project, instead of just like last week, we said, hey, there's this project you got to have partners for. But now we're actually going to talk about what math you have to do, what statistics you have to do, and what the rules are for the project. So that is the plan for this webinar. Are there any questions at all that you might have? Any questions? If there's no questions, I want to remind you all that you can always post your question on the discussion board. I'll always look at it and I'll answer them right away. That's the good thing about these webinars is you can get immediate answers from your questions instead of having to wait hours sometimes to get an answer. I do want to mention I have graded the discussion posts. So you should be able to, and you should get an email out to your LTCC email and make sure that if you don't look at your LTCC email often, have that email get forwarded to whatever you do look at, whether it's your phone or your other email or something like that, so that you get to see it right away. So I did do that. And I want to mention this is very important for the discussion posts because not all of you kind of like paid attention, I think. Make sure when you go to the discussion post assignment, look at my post that I do as a sample post and my reply. And that'll give you kind of a heads up on what is expected. Okay, this is not just you reply to a student saying, hi, I like you, goodbye. No, this is a full analysis of statistics or probability for this week. The other thing I want to mention is that we're in week 2, and 2 is an even number. Why is that important? Which may not make you smile. Yeah, so every even number week you have your test or your exam. And so don't forget there is an exam this week, and that'll go over as chapter 1, 2, and 3. So basically everything we've done. And make sure that you do it. I recommend not waiting till the last minute. Don't wait till Sunday, especially not Sunday night to start working on it, start taking your test because who knows, your electricity could go. So make sure that you give enough time so that you have extra time in case something happens. The exam is 90 minutes. So it's very different than the homework, or whatever the chapter assignments. Chapter assignments, you have an unlimited amount of time. If you get it wrong, you can try again. But for the exams, you don't get to try again. You don't have an unlimited amount of time. You have 90 minutes and then it's over. Okay. If you have a disability and you need extra time or whatever, you need to contact your disability center and we'll make it happen, but you have to go through them. So, that's just some rules about the exam. And the last few questions, you'll be writing stuff, typing, and it'll originally show you got zero points on it, and then next week when I grade it, then it'll give you the points that you deserve for those problems, for those last few problems. So that's just a little heads up on the exam. Any questions? Okay, if there aren't any questions, let's talk about probability. Probability, again, is going to be important. We're going to be using probability throughout this entire course. So let's start out kind of the beginnings. And I want to start out since we are in, or I'm in Tahoe. I don't remember where are y'all? I don't know what city you're in right now. Yeah, Tahoe. One of the big things in Tahoe is gambling. And let you know, I used to be a major gambler and I'm a statistician. And I was a major gambler for things I could win in. And I did very well. So, for example, let's suppose you have a coin. Here's a quarter. And this is a fair coin, just regular old coin. And I flip the coin and look at it and say, what is the probability if I flip the coin that it'll be heads? Now, I hope that you all know that probability is half. Okay? But it's important to understand the reason. The reason is you look at the coin, and this is very easy. There's a head and there's a tail. There are two sides of the coin. And if you want the probability of getting heads, only one of those sides is a head. So the numerator, this top of the fraction, is the number of ways that makes what you're looking for happen. The denominator are all the different things that can happen. And we're assuming that all the different things have equal likely chance of happening. With a coin, that's pretty true. Okay. Then there is picking a card. So I have these cards, and if I pick a card, I want to say, what's the probability that card is a spade? How many cards are there in a deck? Do you know? I know not everyone plays cards, but how many cards are in a deck? Put in the chat box. How many cards are there in a deck? Yeah, there's 52 cards in a deck. Okay. There's a lot of them. And you may or may not know this, but there are, of those 52 cards, 13 of them are spades. There's an ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, and 2. That's 13 cards that are spades. So the numerator will be 13 and the denominator will be 52 because there's 13 spades out of a 52 card deck. Any questions on these very simple probability questions? I call them simple because all you have to do is count. And it might take a while to count, but it's not hard. Any questions? Okay, so those are very simple examples, and there are many, many examples. So here's the formal definition of probability right here. And that is the probability of an event A occurring is the number of ways A can occur divided by the total number of things that can occur. This is again assuming that all the different things have the same chance of occurring. So the probability of A is the number of things in A divided by the number in the entire set. Any questions on that idea? Okay, so let me give you another example. I just picked two cards. How do we find the probability that both of these cards are kings? Okay, that's a lot harder than the original question, than the first couple that I did, or the what's probably you get a spade, because now I got two cards. Any questions on this question first? Okay, if not, let's go ahead and do this. This takes some work. So what I'm going to do is first, I'm going to say, what is the probability that the first card is a king? So here's the first card. I got two cards, and the first one's a king. Well, there are 52 cards in the deck, and there are four kings. King of hearts, king of spades, king of diamonds, and king of clubs. So I'm going to call that P of K1 for first king. The numerator is 4, because there's four kings, and the denominator is 52. Does that make sense? Okay, our goal is to find the probability that both are a king. Okay, so what we want to do is we're going to first, once we found the probability the first is a king, now let's find the probability that the second is a king if we know the first is a king. So let's pretend that you saw this guy. This is a king. That was our first card. You want to know about the second card. Okay. So the notation we're going to use is the following, is this right here, is P parenthesis K2. We have this little line segment, vertical line segment, and then K1. And the way you read that is the probability that we have a second as a king given the knowledge that the first is a king. Any questions on this idea? Okay, so if I told you this first card is a king, and you want to find out let's mix them again. You want to find out the probability the second card is a king. Okay, how many kings are left for this to be? How many kings are left for this one you haven't seen to be? You can put the chat box. How many are left? Yeah, there's 3, because we started with 4, but we know it's not this king of spades, because that was our first card. So that means that the numerator will now be 3 and not 4 anymore. How many cards are left for it to be? How many different choices are there for this guy? The one that we haven't seen yet. Yeah, 51, because we know it's not this king right here, this king of spades. And there's 51 cards left for this one to be. So that's 51. Any questions on that? Okay, then the next thing we're going to do is we're going to use the multiplication principle. And here's what it says. The probability of A and B is equal to the probability of A times the probability of B given A. Okay, that's a big principle, big formula for probability. I recommend writing that down. because you're going to use it a lot. So when you're doing assignments and stuff, you want it right in front of you, especially for chapter 3. Okay, so that's the multiplication principle. So we want to find out this probability. Well, the good news is we have all these numbers. So the probability of A is the probability the first is a king. That was 4 out of 52. And for the probability of B given A, that's the probability the second is a king given the first is a king. That was 3 divided by 51. Any questions on that? Okay, so I do want to give you a heads up. There's a lot of math today. Okay, whereas in the last chapters, there wasn't a whole lot of math to do. Now we have a lot of math. Okay, it's pretty basic math, but you got to do it. In this case, is multiplication. Okay, so I do want to also give you another suggestion, and that is that you do not have to do this by hand. I will never tell you that you have to do calculations by hand. Okay, because I don't know, maybe that's what you love doing, taking 4 divided by 52 and then multiplying by 3 and then dividing by 51. That'll take a long time, but it's really simple to do it in a calculator. And I actually did it in my calculator, and I got 0.00452 and more stuff. And in fact, if you want to see, there's a lot of different ways of doing it. One, if you go to this calculator here, and you go to pretty much any of them that we've been doing. So for example, if we go to that one variable stats calculator, there's a lot of ways of getting to calculators, but I want to show you one of them. If I click scientific calculator, there's a nice little pretty easy calculator, the little fraction button, and I can do 4 and then 52, 4 divided by 52, and then I multiply. So I click the times sign, and I click the fraction again, and now 3, and then over 51. And there's our answer, 0.004524886, etc. Any questions on the calculator and the calculation? Yeah. Notice, by the way, if I randomly pick 2 cards, it's very unlikely to get 2 kings, because this is less than a hundredth of a chance, right? Less than a percent. Okay, it's not even a half of a percent of a chance. 0.0045 or so is tiny, tiny. Okay, another note, and this is important: probabilities can never be negative, and they can never be bigger than 1. Okay, if you ever are calculating a probability, you get something bigger than 1, find your mistake, because it's wrong. You can't have 180% chance of something. Is that clear? Okay, so that's just a big heads up, is that you should get a kind of a probability that looks reasonable. And hopefully you know that it's not very likely to pick 2 kings, so it's not a very large probability here. Any questions at all about this example? Okay. Let's suppose you pick 5 cards from a poker hand, for a poker hand. Any of you play poker? Or at least know a little bit of the rules? I used to teach a class called the Mathematics of Poker. Haven't taught that in a long time. Any of you play poker? Okay. So a poker hand is 5 cards that are randomly selected. Okay. And we want a probability of the royal flush. Royal flush means you have an ace, king, queen, jack, 10, all of the same suit. Okay. So you need to find out what is the probability Let me erase these and we can get to them later because I realized I forgot to erase. We want to find out the probability. So you want to say, how many royal flushes are there? Well, you could have an ace, king, queen, jack, 10 of hearts. That's one. You could have an ace, king, queen, jack, 10 of clubs. That's two. You can have an ace, king, queen, jack, 10 of diamonds. That's three. Or you could have an ace, king, queen, jack, 10 of spades. That's four. So the numerator will be four. The denominator is actually much harder because how many different ways are there of picking five cards? And just a note about poker, if you have an ace, king, queen, jack, 10 of hearts, say, that's exactly the same thing as a 10, jack, queen, king, ace of hearts. The order at which you pick the cards doesn't matter at all. So this is order independent. Any questions on that? All right, so I'm going to go back to my calculator. I'm going to show you how we calculate that. We're going to go to this number 5. That's where we are in the class now. Combinations and permutations. And here we have, there's a CNR and a PNR. And just to note, CNR is combinations, and that's when order does not matter. PNR is permutations, that's when order does matter. Okay, for poker, order doesn't matter. So our N here, there are 52 cards in the deck, and we're picking 5 of them. Okay, I'm not going to go over the formula because it's kind of complex, but I do want to show you how to use a calculator. And then I click Calculate CNR, and there's my how many there are. Notice that there's over 2.5 million different ways of picking 5 cards. There is no way in the world you would ever be able to list all the different things that you could get. That's millions. Good luck. But you can use a calculator or math like me if you love math, and you can find out how many different ways there are of picking these numbers. And that is 52, choose 5. So I'm going to click copy. I'm going to paste it. So our probability of getting a royal flush is 4 out of 2,598,960. Okay. Or if I go to the scientific calculator, that's 4 divided by that messy number. And I want to show you this because this is important. Is the probability around 1.539 or so? Is that close to what the probability is? What do you think? No, remember I told you the probability can never be bigger than 1. And what am I missing? What am I not looking at? Or I'm looking, but I'm not saying it at least. But what did I not look at and use in looking at the probability? You see what I'm not seeing or not that I hadn't talked about? No, you can't have a negative probability either. That's not possible. Okay, so here's what it is. It's right here, this times 10 to the negative 6, which on some calculators, including mine, you'll see E negative 6 means the same thing. What that is called scientific notation. What that says is I'm going to take this decimal point next to the 1 and move it to the left 6 places. The first time it just gets moved, and the next 5 places you're going to get zeros. And that's why you get 0 point, and then 1, 2, 3, 4, 5. And then we had a 1539 about. And now that's a possible probability because now we have a number that's at least as big as 0 and no bigger than 1. Any questions? Any questions at all on this example and kind of understanding scientific notation, which does happen sometimes. Okay, so here's another question. Let's suppose that there is a test. Okay, you're taking a test, and it's a multiple choice test. It's got 20 questions. And there's 4 choices for each question, like an A, B, C, and a D. And let's suppose you actually forgot to study for the test at all, and all you could do is just randomly guess on each question. What's the probability of getting them all right? Do you think it's likely or do you think it's unlikely? If there's 20 questions, multiple choice, four choices each, and you just guess on all 20 of them. You think you'll do well? You think you'll get them all right? Yeah, incredibly unlikely. So let's take a look. Okay, in this case, the way you do this is you say, well, these are what's called independent of each other. It doesn't matter if you look at the probability of the first one, that will be 1 out of 4. I guess I have to do it this way. So that'll be 1 divided by 4. The second one will also be 1 out of 4, because every time you got a 1 out of 4 chance of getting it right. So it's going to be times 1 out of 4. What's the probability of getting the third one right? One out of 4. So I can go dot, dot, dot times 1 out of 4. Because they're just all 1 out of 4 chances. What's an easier way, especially with a calculator, in going 1 out of 4 times 1 out of 4 times 1 out of 4 20 times? This is important. So what's a shorter way of writing that out, and in particular typing it in a calculator? Remember? Any of you know? Because I don't want to type this so much. Yeah, it's exponents. So I can rewrite this as 1 out of 4. And then to the 20th power. And that, just go back to our calculator. And you just go 1 out of 4. And then to the power, you could either hit this A to the B or a little caret, you choose, 20. And again, in scientific notation, that happens a lot. That's going to be, it says 9.0949 to the negative 13th power, which is literally 0.000000000000. I said it's 0.0000000000000900949, which is almost no chance. Any questions on that idea? So we're doing a lot of almost no chances. Okay, so just a note, and kind of something I just somewhat mentioned, if you're allowed to repeat the answer, it's called with replacement. And if you do it with replacement, then they're independent, and more generally, if the probability of A and B is the probability of A times B, then it is called independent. If they're not equal, then it's dependent. So in terms of kind of getting a good feel for it, if knowing what happened on the first one doesn't tell you anything about what happened on the second one, then it's independent. If knowing what happens on the first one changes the probability for the second one, then it's dependent. You get the idea on that? So just an idea, something I use this for. Not anymore, but I used to. And that is, I used to be a card counter. So what I do is I would go to the casinos. I would go to blackjack actually, watch the cards, and then I would look at the cards that have been played. And then based on the cards that have been played, I can recompute the probability in my head. And then I can make better decisions on, what to do in the playing of the game. Does that make sense? And that's what card counting is. And I will tell you, it's very complex, but something I did, and I made a lot of money actually. Any questions on that idea? And that's because when you're picking cards, they're not dependent, right? Because if you already saw the first card, you saw it as a king, the next one has a smaller chance of being a king, right? Okay, any questions on this? Okay, let's do another example. Here is the lottery. This is Powerball. Okay. Okay. And by the way, anyone know how much you win if you win Powerball? Any idea what it is today? It changes every day, by the way, or twice a week. You win $285 million. Pretty good, right? Do you think it's a good bet? What do you think? Okay, so for example, do you have more than 1 out of 285 million chance of winning? Any questions on the question? Okay, I don't expect you to immediately come up with it, but let me show you what you do. So let's suppose I bought 2 tickets. Okay, and it turns out if you buy 2 tickets, it's going to cost $4, I guess. And so you better have better than 4 out of $285 million. And it's a little more complicated than that, but for now, we'll keep it simple. So here is the way you play. You actually pick 5 numbers between 1 and 69. I'm not sure how much you can see that, but there's these first 5 numbers, and that's just regular numbers. And then there's one power number between 1 and 26 that you also pick. So what you need to do is you need to say, what is the probability of winning the lottery? So first thing, if I bought 2 tickets, then the numerator is 2. Any questions on that? Now let's look at the 5 numbers between 1 and 69. If I want how many different choices are there for numbers between 1 and 69, we've already done something very much like it. We go to the calculator with combinations and permutations. Order does not matter, by the way, when it comes to the lottery. So now we have 69 different numbers. And we have R is 5 because you're picking 5 numbers. I hit calculate. Let me go make sure I refresh this so it does it. There we go. 69. R is 5. And I hit calculate. And there are 11,238,513 different ways of that happening. So that's how I got this 11,238,513. Okay, but there's the power number between 1 and 26, and those are independent of each other, which means I can multiply. So I'm going to multiply by 26. And when I calculate that, there's my probability of winning. Okay. By the way, do you think it's a good idea? Do you think if you play a whole lot, you're going to end up winning money for this Powerball? Okay, on average? Or do you think you're going to lose money on average? What's your guess? Yeah, for this example, actually you're going to lose money, but we're not going to understand completely how to calculate that until next week. And then we'll talk about, how do you find out whether you're going to like lose money, if lots and lots of people play, or if you buy lots and lots of tickets, are you going to lose or win? In this case, you're going to lose. It turns out that there are times when you're going to win, or on average. And when that happens, I actually buy tickets. I don't spend $1 million in it because, there's a high standard deviation, it turns out. And I can't lose everything I've got, you know what I mean? So I don't bet millions of dollars on it, but I buy $4 worth. So just let you know that that's something that you can use statistics for. When is it a good bet? And when's it not a good bet? Okay, for all kinds of things. Okay. I will let you know that for almost all the games in the casinos, they're bad bets, but they didn't used to be if you're a card counter. Okay, that's a long story though. Any questions on this probability idea? Okay, so now that we know that, let's go to another example. Okay, a lot of times probability examples are going to they're going to be big long word problems, and you have to be able to read the sentence or the sentences and be able to understand how to solve this. Okay, so let me read this out. Okay, so step one on a long word problem is to read the words. Hopefully that's obvious. Okay, so here it is. Suppose that 20% of all students taking stats at Lake Tahoe Community College are African Americans. Okay, and 40% of all students at Lake Tahoe Community College are non-STEM majors. If 22% of Lake Tahoe Community College students, or Lake Tahoe Community College stat students, non-STEM majors, are African American, and you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. Any questions on at least what it's asking and what it's saying? So step one, read it. Any questions on step one? Okay, step two is read it again, but this time much slower. And every time we see a number, decide what that numbers is in terms of probability. That's the probability of something. So now let's go through. Suppose that 20% of all students taking stats at Lake Tahoe Community College are African Americans. So that 20%, first thing, 20% is 0.2. Hopefully you know that. That's a probability. And it's a probability that if you randomly select a stat student at Lake Tahoe Community College, that person is African American. So what I can do now is I can type in P, parentheses A, is equal to 0.2. So let me ask any questions on how I read that sentence or that part of the sentence, that phrase, and turn it into symbols, because that's going to be often the hardest part. It's easy to watch me do it, but doing it yourself, you got to force yourself to really read it. And then when we have that, since it's a probability of being African American, I just use the first letter, which is the easiest to do. Okay, especially when it's like A. O, sometimes you got to be careful because it looks too much like a zero. but A works well. Any questions on that? Okay, now let's read the next piece. 40% of all stats students at Lake Tahoe Community College are non-STEM majors. Okay, so that is a probability if you randomly select a stat student at Lake Tahoe Community College, that that person is going to be non-STEM. Any questions on the idea there? So we need a letter for that. How about the probability? How about N for non-STEM? Sounds good? Is equal to, and again, 40% is 0.4. Any questions on how I came up with those two ways of writing these numbers as probabilities? Okay, now we read the next piece. If 22% of Lake Tahoe Community College student non-STEM majors are African American. Okay, so now you got to be able to read this piece and understand what it's saying. Okay, first thing, the probability will be 0.22. What's it the probability of? So what we're saying is that of the non-STEM majors, 22% are African American. So we're saying if you only look at non-STEM majors, then there's a 22% chance of that person being African American. So we're given that we're only looking at the pool of non-STEM majors, and we're trying to find the probability, or we're saying the probability of being African American is 0.22. So it's a given question. So I'm going to go P of African American, that's A, given that's that little line segment, N for non-STEM is equal to 0.22. Any questions on that? That's usually the hardest part right there. Any questions? Okay, then it says if you randomly you pick a randomly selected African American taking stats, find the probability that the student is non-STEM. So now what you're doing is you're saying we are given that they're African American, find the probability that they're non-STEM. We don't know the probability. So what I'm going to do is I'm going to write down what I want, which is P of N given A, and I'm going to write equals question mark, because that's my question. If you don't know what your goal is, you'll never get there. So let me stop for a moment because this is hard for a lot of people. Are there any questions at all on how I came up with any of these probabilities or what the question was, what probability the question is asking for? Any questions on that? Because that again is that's the challenge usually. Okay, once I have that, then I can use the big formula. Okay, and we already had this formula. Probability of A and B is the probability of A times probability of B given A. But when you have A and B, that's the same as B and A. So that's also the probability of B times the probability of A given B. So here's what we can do. We can take this second one and we can divide both sides by the probability of B, P of B. And what I get is the probability of A given B is the probability of A and B divided by the probability of B. Any questions on that? Is that clear? Okay. Well, the probability of A and B, again, that's the probability of B times the probability of A given B. So I can say the probability of A and N is the probability of N times the probability of A given N. Probability of N, that we already wrote up here is 0.4. So there's the 0.4. The probability of A given N, that we have up here is 0.22. So that's 0.4 times 0.22. Any questions on that? So now we just put everything together. Probability of n given A is the probability of A and N divided by the probability of A. Probability of A and N that we just calculated was 0.4 times 0.22. Probability of A was 0.2 because that we already found. So I take 0.4 times 0.22 divided by 0.2. And that, if you use a calculator, you get 0.44, or if I do it in my head. Any questions? Any questions on this? Do you believe me when I tell you this could be really hard? In terms of deciding what to do? The math is actually quite easy. The deciding what you need to put into the formula, that's hard, and what formula to use. The math is just multiplication and division that you use a calculator, so that's never hard. Any questions? Do you all believe me that it's hard? Or are you looking at it and say, oh, this is easy. I'll have no problem doing any of this. What do you think? I don't see y'all jumping in. Yeah, so here's my big suggestion. That is practice, practice, practice. Look at examples and try doing your own too. Okay? And you do that, again, you can go to the homework, the chapter assignment, and you can do it and do it and do it again. Any questions on that? Okay, so let's do, okay. And by the way, just a note, just to say it again, these are key formulas. These are the ones we just looked at. Let's do another one. Let's suppose you roll 2 6-sided dice. Here's some dice. And I roll them. And I just rolled them. So you roll 2 6-sided dice. Find the probability the sum of the dice is a 5. So for example, there's a 4 and a 1. We're going to find out the probability that the sum is a 5. Okay. That gets a little interesting. And the idea on this one, we're not going to use any fancy formulas for this. Instead, what we're going to do is we're going to think about the definition of probability. So we did that at the beginning, but now we're doing one that's a little harder. And we're going to count. How many different ways are there of having 2 dice come up? How many different ways are there? How many different answers are there for the first die? That's easy. How many different answers are there? 6, right? There's a 1 through 6 for this die. Does that make sense? So just to note, if this is a 1, then for the next die, there's 6 choices, right? So we could have a 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And similarly, if this is a 2, you have 6 choices. If it's 3, you have 6 choices. So how many total choices are there for the 2 dice? What math do I have to do? It's very simple math. Thoughts? Okay, it's not 12 because remember there's 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1. That's already 13. So it's not 6 times 2. What is it? So for each number here, there's 6 of these. And there's 6 different numbers this could be. So it's 6 times 6. And that's 36. Any questions on that? So there are 36 different combinations, things that could happen with the 2 dice. How many ways are there of getting a sum of a sum being a 5? Now we're going to just count them. So we have a 1 and a 4. What else could we have? Yeah, 2 and a 3. We could have a 3 and a 2. And we could have, dropped it. We could have a 4 and a 1. So how many is that? That's 4. So it's 4 out of 36. And that's the probability of having the sum being a 5. Any questions on that? Okay, so the last type we're going to do is called contingency tables. So let me give you I'm going to do it by example because it's the easiest way. So let's suppose, when I say suppose, I'm just making it up, but it could happen. Let's say a survey was done asking Lake Tahoe Community College transfer students where they plan on transferring to and what living situation they will be in when they transfer. And what I've got, and I did make up these numbers, so don't quote me on them, but you could do the survey if you needed to, is we have Cal State universities, we have UCs, University of California's, we have UNR, University of Nevada, Reno, and then we have other. Okay. And then the different living situations, you could live in an apartment, you could live with your parents, or you can live in some other situation. Okay. And who knows, that could be homeless, maybe you have your own house for all you know. Okay. And this is a table, and the way you read these numbers, like this number 33, means that from the survey, there were 33 students who said, I'm going to go to a UC campus and I'm going to live in an apartment. Any questions on how you read this contingency table? Any questions? Okay, so what we want to do is, the first thing is find the probability that a randomly selected student will go to a UC campus or live in an apartment. Any questions on the question? Okay. And just to note, so we don't have to waste our time, if you add up all these numbers, you get 246. Sound good? Okay. Again, so you can stick them in a calculator and you get that number, but I don't want to waste your time. Any questions on the question? Okay, so here comes another big formula. As I mentioned, there's a lot of big formulas today. So another one to write down, and that is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, and the idea of that, so what we want is UC or apartment. So the problem is if we added up all the UCs and then we added up all the apartments and we added those together, I'm going to double counting the 33. Do you see that? And that's why you have to subtract the probability of A and B, because otherwise you're going to double count that 33, because you'd say, well, the apartmenters, people who want to live in an apartment, are 43 plus 33 plus 19 plus 22. Add those up. And the UC, people who want to go to UC, are 33 plus 8 plus 19. The problem is I said 33 two times. And that only gets to be put in one, because every student gets chosen at most one time. Any questions on that? So we just calculate that. So the probability of a UC being a UC student, well, that's 33 plus 8, which is 41, plus 19, which is 60. So that's 60. And there were 246 total, so 60 over 246. The probability of A, that's probability of living in an apartment, That is going to be 43 plus 33, which is 76, plus 19, which is 95, plus 22, which is 117. Again, you don't have to do it in your head like I just did. You're always welcome to use a calculator. So I get 117, and we're still over 246. That's how many students we've got. But then again, we've double counted. We got to subtract the probability of A and B. There were 33 that were UC and want to live in an apartment. So I need to subtract 33 over 246. Any questions on this idea here? Okay, and you can stick that in a calculator if you want. Maybe I'll do that, equals. So the easy way, by the way, the denominator is all the same, so you can put the numerator together and just divide by 246. 60, 117, 33. Plus 117 minus 33. So 60 plus 117 minus 33. And that was divided by 246. And there we go. Probability is about 0.5854. Okay, which is a pretty high chance, a little over 50% chance. Any questions on this example? This is called a contingency table. It's kind of a table where you have two things going on, and it gives you the number in all those situations. Okay, so now comes the next one, next big definition, and that is two events, A and B, are called mutually exclusive if the probability of A and B is equal to 0. Okay? So if the probability of A and B is equal to 0, kind of the idea is that means A and B can't happen. Can't have both of them happen. Okay, but what you really have to do, and this one I'm going to make you do for some of the written things, is you have to actually do the calculation to show that it's not 0. So here's an example. Are transferring to a CSU and living with parents mutually exclusive? Any questions on the question? Okay, well, what you can do is you can go and you could say, well, transferring to a CSU and living with parents, that has 34 in the numerator. So 34 is in the numerator, and we had 246 students. And hopefully, 34 divided by 246 is not 0. So since it's not 0, they're not mutually exclusive. I'll often abbreviate ME for mutually exclusive. Any questions? Any questions on the mutually exclusive idea? So it's not that hard. It means they can't both happen. Okay. And which is the same thing as the probability of A and B is equal to 0. Okay. I kind of mentioned this one already about independence, but now I'm going to give you the more formal definition. Two events, A and B, are called independent if any of the three formulas are true or equations are true. First is the probability of A and B equals the probability of A times the probability of B. The second is the probability of A given B is equal to the probability of A. And the third is the probability of B given A is the probability of B. Okay? So what this tells you is that if you're told what B is, that does not change the probability of A at all. And also tells you if you're told what A is, it doesn't change the probability of B at all. There's probability of A and B equals probability of A times probability of B. That one's a little harder to understand conceptually, but it's a nice formula. Any questions so far? Any questions? Okay, so are living in an apartment and transferring to UNR independent? Okay, so you could do any of those three. It's all up to you. I just let you know this first one. You'll notice this first one, you have to calculate three different probabilities. Probability of A and B, probability of A, probability of B. The other two, you only have to compute two probabilities. So the other two are often a little bit easier, not always, but often a little easier. So let's do the first one, and that is the probability of an apartment given UNR, and we want to say, is that the same as the probability of living in an apartment? So now let's look at this given, probability of apartment given UNR. So if we're given that they're in UNR, that means that we're only looking at the UNR transferring students. And we ignore the rest of them because we're given that they're in UNR. The number who want to go in an apartment is 19. Do you see that? The total number of UNR students, or want to go to UNR, is a sum. 19 plus 7 is 26, plus 15 is 41. So we get 19 over 41. Did I calculate wrong? 20, 36, 41. Oh yeah, I typed it wrong over here. Okay, so 19 over 41, we can calculate that. Okay, 19 divided by 41 is about 4.46341 or so. I think I had it wrong in my original notes. Okay, probability of living in an apartment. We'd already calculated that there were 117 over 246 for the probability of living in an apartment. We already actually found that. So 117 over 246, let's calculate that. And I get 0.4756 or so. Are these numbers the same? Are these probabilities, the probability of apartment given UNR equal to the probability of apartment? Do you think? Are they equal? I don't see you put it all in the chat box. So yeah, they're not. This is 0.46341. This is 0.4756. They're pretty close, but they're not equal. So that means they are dependent. Let me kind of give you a way of thinking about kind of examples where they might be independent, might be dependent. Let's suppose that A is the event that a student is a physics major. And let's suppose B is the event the student is taking a math class. Do you think those will be independent or dependent? What do you think? Notice I haven't given any numbers. Yeah, those will be dependent because if you know someone's a physics student, they're probably more likely to be taking a math class. Physics majors have to take a lot of math classes. Does that make sense? Okay. What if instead, let's suppose we wanted to find out what the temperature is going to be. Okay. What's the probability of the temperature in Tahoe, the high temperature in Tahoe tomorrow will be greater than 40 degrees? And let's suppose that we want to find out the probability that the soccer game that you're going to watch in Florida is going to have a score of at least 10 points. Think those are independent or dependent? So the first is being greater than 40 degrees in Tahoe, and the second is having a soccer total score of greater than 10. Yeah, those would be probably almost certainly independent because if you know what the temperature is in Tahoe, that it's greater than 40, that's not going to tell you anything about the score of some soccer game in Florida. Is that clear? So those would almost certainly be independent. Okay, so it's good for you to get a good feel for independent and dependent. Any questions on all this probability stuff? Are you convinced that this is can be challenging? So don't get mad at the messenger. Don't shoot the messenger, please. Yeah, this is challenging. A lot of people consider this the hardest of the entire course. So, it is tough. It is tough. But that we've gone through all of the things that you need to know for chapter 3. So now I want to give you the secret word. The secret word will be dependent. We're not done with the webinar, but we're done with the talking about chapter 3. We still have we have a ways to go. Okay, so the secret word is dependent because that was an important piece of probability, right? Deciding if they're independent or dependent. So dependent is a secret word. I try to make something relevant, but not something you're going to immediately just guess if you didn't watch this webinar. So don't forget to write down the word dependent, and that'll be in your secret word quiz. Okay, as long as you submit it by Sunday of this week, then you don't have to send me your 5 pages of notes. I do recommend taking notes while you're watching these webinars, though, because that helps you focus, and it also, make sure you write down all the important information. It's a good idea to do that. It's going to help you learn. All right, so I don't know if you remember, but do you remember what the last thing I was going to talk about was today? Which is quite important. Yeah, project 1. So now I want to go to project 1. So now there's no notes to look at. Now we're just going to go back to the course. Okay. And by the way, what I did is now the modules are will be your first thing to see when you click on the course. Huh? And if you want to find out about the project, click on syllabus. Okay, that used to be the first thing to go to, but now modules are more important. So if you go to syllabus, and if I scroll down, there's projects. And I do want to remind you, hopefully you all have partners already, but you must have partners. It's a disaster if you work by yourself, by the way. Automatic 25% penalty, which means it's almost impossible to get a passing grade in project 1 if you don't have a partner. And it is impossible to get an A or a B. So don't even think about working without a partner. That's just a note. Okay. So some more notes is that the project 1 is due on February 9th. I know that's a long time from now. It's almost a month from now. But again, I like to let you know ahead of time, early, so that if you take some time to do this project, and that way you'll have plenty of time to do it. I strongly recommend not waiting until February 8th to start working on the project. Okay, it turns out you have all the information you need after this webinar to be able to start the project and do the whole thing, which will take time. But just let you know that. And I like to think about timelines. So again, let's note this. February 9th is the due date of the project. I recommend having your draft done several days before that. So maybe by, February 3rd or something like that, having your draft to send me so that I can let you know of all the things that you need to change to get a better grade. Okay. If you don't send me a draft, then I won't know what to tell you. So it is important that you send that draft so that I can help you out. It's really hard to get an A if you don't send me the draft. Not because I'm, mean to you if you don't send me the draft, but then you won't know what to fix. So you send me that draft, sometime before. Okay. And then maybe a little before that, maybe a week or two before that, maybe a couple weeks before that, have your idea of what you're going to be doing for the project. Okay. And what you should do is you should post your idea on the Project One discussion board. And in a little bit, I'll tell you the things that you should probably post in terms of the idea, the details of the idea. Okay. So again, that's important because it's going to take some time to do this project, a few weeks probably. Okay. So just a note on the Project One, if I click on Project One right here, that'll send you to the Project One requirements. And now we'll be able to see all the things that you need to do for Project One. And most of it is pretty much Chapter One and Chapter Two. Okay. So let me explain, read through this, and talk about what it all means. So think of a quantitative investigation where you ask people a survey question that someone might contract out to have done. Who remembers what the word quantitative means? Last week in the week one webinar, I went over that word. Who remembers what quantitative means? Remember? Put it in the chat box if you remember. What does quantitative mean? I know it's been, a week. Yeah, it means that the answer to the survey question will be a number. So what you should do is write down the survey question, right? What are you going to ask each of the people that you're surveying? Okay. Not what your project is about. What are you going to ask them? Write it down in words. Okay. So I'm not saying use this particular example, but let's say you wanted to find out, say how much money people are willing to spend to go skiing for a day. Okay. Well, the survey question would be, how much money are you willing to spend to go skiing? And the person might say, I'm willing to spend $190. Okay. By the way, if you don't live in Tahoe or you don't ski, skiing is very expensive. Just let you know that. And that's a number. 190 is a number. And then that could work. Does that make sense? On the other hand, if you were interested in, I don't know, the percentage of people in Tahoe who like to go skiing, that would not work because your survey question would be, do you like to go skiing? And the answer would be yes or no. Do you see that? And that's not quantitative. So that's a mistake a lot of people make is they try and do a project that's not quantitative and that doesn't work. So what I recommend doing is writing down your survey question and then asking your partners the survey question, seeing what they say as an answer to the survey question. Okay, you're not using them as, the data, but it'll give you like a practice. Okay, you also have to decide on someone who might contract out and pay you money to conduct a survey so that because they're going to be interested in your results. If nobody would be interested in your results, this will not work. I'll also let you know that You don't really have to find someone to pay you money, but you have to pretend that you could. Does that make sense? You have to, in theory, find somebody. Does that make sense? And in your project, you have to identify who that person is. Okay. I mean, it could be President Biden. And of course, I don't expect you to call President Biden. I couldn't call him. He wouldn't answer my phone. But at least in theory, he might be interested in something. You know what I mean? It could be for the ski example, then it might be the chief maybe the head of Heavenly Ski Resort, because that person would be very interested in how much money that people were willing to spend. Does that make sense? Okay, so you should identify who it is. Okay. So the next thing you should do, which I didn't necessarily write, but we'll write down a little bit, you'll see it on the next bullet, is think about how are you going to conduct a survey that has not too much bias involved in it. Okay. You're going to go and perform the investigation. You're going to do the survey. Okay. And you're going to conduct the survey. You're going to ask the survey question. Okay. And make sure you identify what the population is, not just who you're asking, but what the population is. It might be all students who are community college students. It might be all people who live, maybe all adults who live in your town. Who knows what it might be, but you should identify, in theory, who that is. Does that make sense? Okay. In your paper, by the way, you should be talking about why this is important, and also a statement on who's hiring you and why they're interested in hiring you. Okay. Also in the paper, you have to use one of the sampling techniques we've talked about in this class. And here's the choices. You must either use simple random sampling. I will let you know that simple random sampling is almost always impossible. So for almost every situation, that's not what you're going to use because you can't. Okay. If you think you can, you need to explain how you did it. Okay. And if you didn't use simple random sampling, you're going to lose a lot of points. But there's two others that you can use. You could use stratified sampling, which we talked about last week, or you can use cluster sampling. Okay. Those are what almost everyone uses, is stratified or cluster. Okay. Make sure that you go through the steps in stratified sampling or the steps in cluster sampling that you used. And that needs to be talked about and written about in your project. You should also, when you're posting on the Project One discussion board, your idea for the project, you should post your idea for what sampling technique you're going to be doing. Okay. And if you're using stratified, what's going to be your strata? If you're using cluster sampling, what will your clusters be? And which ones will you select? Okay, in your paper, you have to talk about bias that might have occurred due to your sampling technique. Okay, if you think there's no bias, think again. There's always bias. I do not take off points for having bias. I take off points for not describing the bias. Okay, bias involves a misrepresentation of the population, so the sample will not represent the population data. Okay, in particular, what's going to be important is a sample mean. So is your bias likely to make that sample mean lower, or is your bias likely to make the sample mean higher than what the population mean is? Any questions on that idea? Okay, the sample size must be greater than 30. By the way, the number 30 is not greater than 30. What's the smallest number greater than 30 that your sample size could be? It's an easy question, but I want you to type it out because it's a problem a lot of people have. Not one. One is not greater than 30. One is a lot less than 30. So don't even think about a sample size of one. What's a number greater than 30? What's the smallest number greater than 30? It's not a trick question. It's really easy. Smallest sample size you could have that'd be greater than 30. Yeah, 31. Okay, so you can survey 31 people. You can survey 40 people. Okay? I strongly recommend not surveying 1,000 people because that'll just take too much time. Okay. The only reason why you would survey, a whole lot more than that would be if for some reason you have a job that you actually get paid for at work. And this is your boss actually needs the stuff and he needs a much bigger sample size or she needs a much bigger sample size. Okay. So that's really the only reason why you need a very large sample size. But anything over 30 is enough for this class. And this is one of those you just got to trust me. That's going to be a requirement to be able to do good statistics, but we haven't learned that yet. That'll come later, and you don't have to worry about the reason why over 30, but you'll learn about that as we go. Okay. So if you think that you're doing random sampling and you use the word random, you better explain what you mean by it and why you use random because good luck. Okay, you'll almost always lose points because doing random is almost always impossible. Okay. All right. So in your project, so that's the first step is to do that. Then you're going to conduct a study. You're actually going to physically talk to people and you're going to ask them the survey question. Sometimes if you're going to talk to strangers, let's say at a supermarket or something, I strongly recommend the very first thing you should do is say, I'm taking a statistics class at Lake Tahoe Community College, and I'm required to do this project, and I have to ask a survey question. Would you mind answering my survey question? If you say that, almost everyone will answer your survey. If you don't, most people will just keep walking by. Okay, and I'm sure you've been one of those people that doesn't answer a survey question when someone asks. Okay, but if you say you're a student, almost everyone will listen to you, and it's much easier. By the way, if you have a 3 people in your group and you share the responsibility of doing the survey, then if you survey 11 people each, you've gotten enough because that's 33. That's not that hard. Okay, it shouldn't be that hard to conduct the survey. Okay, I do want to mention a couple things. One is you are not allowed to survey children. Got it? Okay. And you don't know why you're not allowed to survey children? It's not just because I hate children, because I love children, but I will not let you survey them. I really, believe in helping kids, by the way, but you're not allowed to survey children. How come? Any thoughts? Yeah, there's very strict national laws against surveying children without all kinds of parental signatures and consents and lawyers and all kinds of stuff. And I don't want any of you to get sued. And the good news is I'm actually being recorded and this is going to be on YouTube. You've heard me say you are not allowed to survey children. So if someone sues you, they can't sue me too because I told you you can't. You're breaking my rule. Okay. Don't even think about surveying children because you can't. You are, if it's a college student, it's a fellow college student who's taking a class with you who happens to be 17 because they started, that's actually the only exception because there's actually a rule that says you can survey a fellow college student. That you don't have to have that like parental consent if it's someone who is enrolled in your class. But otherwise, you cannot survey any children. Got it? Okay, don't even think about it. Okay, so that's one of the big rules. Okay, after you do the survey, you are going to put it into the spreadsheet. So let me remind you. This is the spreadsheet. And in fact, if you go to this one, then this is a spreadsheet. The first thing you're going to do is you're going to highlight. Actually, the very first thing you do, and I already showed you might have already done it, is you're going to go to File. Then you're going to go to Make a Copy. And then give it a name and hit Make a Copy. I don't have to because I've already made my copy. Okay. And that way you have it, and then you can share it by clicking Share. And you can share it with your partners. Okay. So that way you can all use the same spreadsheet. You can see it together. You can change things and everyone will see the changes. Okay. Once you've done that, what you're going to do is you're going to highlight all these numbers. You're going to hit backspace so that you can start from scratch. Then you're going to type in your values. So let's suppose you had 34, 23, 55, 36, 18, 99, 14, 2, 37. So these are your data values that you might have gotten: 45, 66, 22, etc. Okay, I'm not going to waste your time, but you're going to have more than 30 numbers. You got to have at least 31. Okay, and then it's going to give you everything you need. Gives you the minimum, the mean, the sample variance. Sample variance you're not going to do much with. Sample standard deviation, the median, the maximum, Q3, N. It's going to give you Q1. Don't worry about confidence level. Don't even think about that. Don't include that in your project since we haven't done that. Okay. And there's no T or P value, but it'll give you a Z-score. And again, you have to decide what you want the Z-score for, and you can do it for many things. I talked about this last week. So go back last week and you can see you can also get a histogram, you get a stem and leaf, and you get a box plot. So you can get all those things. Okay. Then in your project, you're going to include all relevant charts. Okay, that must include a histogram, a stem and leaf, and a box and whiskers plot. Notice, because you need the stem and leaf, your survey question better have at least 2 digits. Because if everything only has 1 digit, then stem and leaf are useless. So make sure you have at least 2 digits for your survey. So for example, if you want to find out, I don't know, how many times a person had breakfast this week, don't ask that, because no one's going to say 14 for breakfast. So instead, you would change that to how many times have you had breakfast maybe in the last year or in the last month. Do you see? Because then you'll have 2-digit numbers. So it's important that you're going to get a bunch of 2-digit numbers for your answers. Okay. You can include a pie or a line plot or, other charts. Okay. Just note you have to use our spreadsheet. Okay. Or at least some other spreadsheet if for some reason you can't make that work. Okay. This is not a comparison study. So in your spreadsheet, you're only going to have 1 column in the spreadsheet. Don't even think about 2 columns. So if you're doing stratified sampling, in the end, you're just going to put all your data in 1 column. You're not comparing the strata. Got it? It's a typical mistake people make. Okay, so you're going to be explaining what those charts are and what they tell you, and in particular, what decisions will the client make after seeing the charts and the information the chart gives. Okay, throughout the whole paper, you can be writing the decisions the client makes. Okay, you're also going to get a list of the summary statistics. That's the mean and the standard deviation and all those others. Okay, and make sure you pay special attention to standard deviation. That's a main part of this project. You must have at least a full paragraph, okay, to receive an A. You're going to lose a lot of points if you don't have a full paragraph just on the standard deviation, what it tells you. Notice, remember the empirical rule and Chevyshev's theorem, that involves a standard deviation. One of those is going to be, so the empirical rule may or may not be useful. If it's useful, use it. If it's not, you have to use Chevyshev's and explain why. Okay. What does it say about the population? How about Z-score? Okay. Discuss how the Z-score is used for a study and maybe for a few different values of X. How is that going to tell you about the about outliers. Okay, based on the z-score, what can you say about outliers for different values of your data? Okay, interpret all of it in the context. Don't just state the definition. Make sure you talk about how the client is going to use the information. Got it? Okay, just note this is a paper. Okay, it's a written paper, and written paper should have a beginning. Okay, it should have a middle, and it should have an end. Okay. Okay, so that's really important. So the end will be like the synopsis of your findings, the main points of what you found, and how for the main points, what is the client going to do based on it? Okay. You should also, at the end, talk about recommendations. Okay. You should also at the end talk about how you could maybe remove the bias with the new survey. Does that make sense? So how might you make a better survey? Okay, not that you can actually do it, but if you had a lot of money and a lot of time, how can you improve on the survey so that you can make the bias not as bad? Any questions on that? And also, what might you do to get more information with the further study? That might be other survey questions you can ask that are related. Any questions on all this stuff? Okay. I do have a link on drafts, feedback that I did on Project One drafts in the old days. Okay, and you can look at that and take a look. Any questions at all about the project? Okay, there is no minimum number of pages to have on your project, but typically a good project is typically between 8 and 15 pages, depending on, how much you write. Okay. So maybe 12, 13 pages, but it's not like, I'm going to take off points if it's on the, a little less or a little more. But if you think you can do this whole long project, all this stuff I've just talked about in one page, think again. That's not going to happen. One more thing, when you're in the spreadsheet, what you should do is you should take a screenshot of the spreadsheet. So this part here. Okay. And put that screenshot in your paper. You should copy and paste the histogram. You should also copy and paste the stem and leaf plot. And you should copy and paste the box plot. And make sure those are actually in your paper. Got it? So those have to be in. Okay, so you make a screenshot and copy and paste it in. So that is important. Any questions at all about all this stuff? Because we're about done. And if there's no immediate questions, I think I'm going to stop the recording because we've now talked about everything that I have to talk about. But again, I'm always happy to answer questions if you have questions you didn't want to be recorded for some reason. So let me stop the recording, and thanks for listening for those who are watching it recorded.